right, we're going to go ahead and go over the review for chapter 6, 6.1 and 6.2. Okay, you guys are taking your review. Before we start going over this, I'm just going to write down some information that you guys have to know, okay? What I like to call it is just brain dump. As soon as you get your paper, write this down so you have it. So I'm just going to go ahead and write it up here at the top corner. Again, things that you should know, you have to know in order to solve some of these. The first thing is degrees to radians. You have to know that you're multiplying by, that's pi over 180. Now, if you're going from radians to degrees, you're multiplying by 180 over pi. Now, when you're writing something in degrees, you guys have to have the degree sign in the end. There has to be a degree sign. You will get points off if there is no degree sign. So make sure you remember to write that degree sign. Another thing you have to know is your 6 trig functions. Okay, so just writing that down will help you with a lot of the questions. So I have sine theta. Okay, remember we're using x, y, and r. So this is going to be y over r. Cosine theta is going to be x over r. And tan theta is going to be y over x. Okay, now the reciprocals for these, I have cosecant theta is going to be r over y. I like writing them next to each other so I can know what the reciprocals are. I have secant theta, which is r over x, and then cotan theta, which is x over y. Okay, so that'll help you with those trig functions. Now, another thing to remember is what's positive in my quadrants. I have quadrant 1, 2, 3, and 4. To remember is all students take calculus. And this is telling me which ones have to be positive. So all of my trig functions are positive. For this one, it's going to be sine and cosecant are going to be positive. For this one, it's tan and cotan, that's going to be positive. And this one's cosine and secant that are going to be positive. So you'll see where this comes into play with the questions at the bottom when we're solving these. All right, let's go ahead and we're going to go ahead and start solving these. So it says, find a positive and negative coterminal angle to negative 625 degrees. So you have to have a positive and a negative. If you're only giving me one, that would be incorrect. You have to have both. So looking at this one, positive and negative, I'm going to go ahead and do my positive first. Finding that positive, I'm going to take that negative 625 and I'm adding 360. That's still going to give me negative 265. So because it's still negative, I'm going to go ahead and add another 360. And adding another 360, I'm going to get 95. Don't forget that degree sign. If you do not have a degree sign, it will be incorrect. So this is my positive coterminal angle. Now let me go ahead and find that negative coterminal. So I have negative 625. I'm going to go ahead and subtract 360. And that's going to give me negative 985. And don't forget, you have to have the degree sign. Okay, so coterminal, adding or subtracting 360 if it's in degrees. Now, if it's in radians, I have to add and subtract 2 pi. So trying to get that positive, I'm going to go ahead and take 14 pi over 9 plus 2 pi over 1. Keep in mind, you have to get the same denominator. So that means I'm going to multiply top and bottom by 9. And I'm going to end up with 14 pi over 9 plus 18 pi over 9. And if you add correctly, you're going to get 32 pi over 9. And that is my positive. Now going ahead and finding that negative, I'm going to go ahead and still do 14 pi over 9, but now I'm subtracting. I'm going to use 18 pi over 9. Why? Because if I still use 2 pi, I'm still going to have to try and get that denominator of 9. So then I'm going to multiply top and bottom by 9, and I'm still going to end up with 18 pi over 9. So if I subtract correctly, I'm going to end up with negative 4 pi over 9, and this would be my negative coterminal. Okay, now looking at the next question, it says, draw the following angles. Okay, so when you're drawing your angles, you have to remember a couple things. I need to see where you're starting and where you're ending up. So going ahead and doing A first. A is 150 degrees. So going ahead and just doing a rough sketch of my coordinates, I'm going to have 0, 90, 180, 270. Okay, where's it falling in between? Where is 150 falling in between? 90 and 180 does not have to be perfect. So I'm going somewhere over there in that quadrant. And then I have to show in which direction am I going there. Okay, so I'm starting at my initial spot at 0. And I'm going up counterclockwise. And I'm drawing my arrow. So you have to make sure that I see this because I have to know which direction you're going. That's A. Let's go ahead and do B. B is negative 210 degrees. Going ahead and doing the same thing. Drawing my coordinates. I'm going to have 0. Now it's negative. I'm going to go negative 90, negative 180, negative 270. And negative 210 is going to go ahead and fall in between negative 180 and negative 270. And because it's negative, I'm going clockwise, and I'm stopping right there. So again, I have to see this, where you're starting, where you're going, and the line where it's in between. Okay, looking at the next one, C is negative 425. So C is negative 425 degrees. Going ahead and drawing my coordinates. Negative, so I'm going 0, negative 90, negative 80 or 180, negative 270, and I'll just go ahead and put negative 360. So negative 360. Clearly 425 is more than negative 360, and it's a little bit more. So that means I'm going to end up stopping right over here in this quadrant, quadrant 4. But now I have to know which direction. So I'm starting at my 0, my initial start, and I'm going past negative 360, and it's going to look like a swirl. So I have to see that swirl, and it's falling here. So please make sure you guys know how to draw those for that type of question. And let's go ahead and look at the next one. It says, convert from degrees to radians and vice versa without a calculator. You guys are not going to have a calculator for this quiz, so you have to know how to convert. Keep in mind, if you're converting something to degrees, your answer must have a degree symbol. So let's go ahead and solve some of these. Keep in mind, like I said, we kind of brain dumped at the top. We wrote what we needed. Degrees to radians is you're multiplying by pi over 180, and radians to degrees, you're multiplying 180 over pi. Okay, so if we're looking at A, this is in degrees. I have to go ahead and change it to radians. So that means I'm multiplying by pi over 180. If you can cross simplify. Remember, you do not have a calculator. So simplify if you can. I know 5 can go into 145 and 180. So simplifying this, I'm going to get negative 29 pi over 36. And I can't do anything else. It's simplified as simple as it can be. And this would be my answer. Keep in mind it is in radians, so do not add that degree sign. All right, looking at the next one, still doing the same thing. This is in degrees. So that means I'm multiplying by pi over 180. I'm trying to change it to radians. Simplifying this one, what can I use to simplify? I can use 2. Let's say you don't know. And if they're both even numbers, you can use 2. So I'm going to have 24 pi over 90. Can I simplify 24 and 90? Yes. I'm going to go ahead and use 2 again. Okay, and that's going to end up with 12 pi over 30, or not 30, 45. And I could simplify that again using 3. And I'm going to end up with 4 pi over 15. Can't do anything else, so this would be my answer. You have to simplify it as simple as it can be. Okay, looking at the next one, C. Doing the same thing again. This is in degrees. I'm going to go ahead and change it to radians by multiplying pi over 180. I can go ahead and simplify this one using 5. I'm going to end up with negative 3 pi over 36. And I could simplify using 3. Which gives me negative pi over 12. And this is what I would have if it's simplified all the way. All right, going ahead and going to D. Okay, same thing. It's in degrees. I'm changing it to radians by multiplying pi over 180 and simplifying. These are both even numbers. I know I could at least use 2. So simplifying using 2. And I'm going to end up with 76 pi over 90. Simplify again. They're both even numbers using 2. Simplify first. It's a lot easier. I'm going to get 38 pi over 45. And I can't do anything else, so this would be my answer. All right, going ahead to E. This one's in radians. I have to change it to degrees. So solving this one, I'm multiplying by 180 over pi, and simplify if you can. It's a lot easier if you cross simplify first, because then you're getting smaller numbers instead of multiplying to get large numbers. Again, there is no calculator here. I know I could simplify these two by using 5. My pi's are going to cancel out. So right now I have 7 times 36. You don't have to put it over 1. Just go ahead and multiply and you're going to get 252. Do not forget that degree sign. You will lose points for that. So if it's in degrees, it must have that degree sign there. Looking at the next one, F. Changing it from radians to degrees, multiply by 180 over pi. My pi's are going to cancel out. I know I can go ahead and use 10. They both end in a 0. Just finding quick ones. You could use 20 for that if you wanted to. That would have worked out as well. I'm going to have negative 3 times 18 over 2. 2 and 18 can simplify using 2. And I'm going to end up with negative 3 times 9, which gives me a negative 27. And don't forget, you have to have that degree sign. All right, looking at G. Using G, because it's in radians, changing it to degrees, 180 over pi. Pi's are going to cancel out. And I can use 6 for this one. So I'm going to have negative 19 times 30. All you have to do is multiply for this, negative 570. Don't forget it's in degrees. I changed it. Do not forget that degree sign. It will be incorrect. And looking at the last one for this section, still multiplying by 180 over pi, changing it to degrees. Pi's are going to cancel out. I could simplify by using 30. And I'm going to end up with 23 times 6, which I end up with 138. And again, it's in degrees. Do not forget that degree sign. So this should be hopefully one of the easier pages. You guys will definitely see these questions on the quiz. So go ahead and go to the next slide, and we're going to go ahead and solve these. All right, for these ones, it says find the value of the 6 trigonometric functions for an angle theta whose terminal side runs through the points -4 and the square root of 3. So I have to find 6 trigonometric functions. Will you have to find all 6 for your quiz? No. But it's still good to know how to find all 6. We are going to ask you which ones to find. So like we did on the first slide, we kind of brain dumped, that's what I like to call it, with your functions and the rules. So I'm just going to go ahead and write them up here at the top. I have sine theta, which is y over r, cosine theta, which is x over r, and tan theta, which is y over x. Okay, the inverse, I'm going to have cosecant theta, which is r over y. I'm going to have secant theta, which is r over x, and cotan theta, which is x over y. So this is what I'm using to help me find these. Okay, keep in mind, I do know my x and my y. So for these, I have to have x and y and r, okay? So looking at this one, I have x, I have y, and I have to go ahead and find my r. So just labeling, I have x, which is -4. I have y, which is the square root of 3. And I'm going to solve for r. How am I solving for r? X squared plus y squared equals r squared. Okay, so plugging in and solving, I'm going to have -4 squared plus the square root of 3 squared equals r squared. I'm going to get 16 plus 3 equals r squared. And that adds to 19 equals r squared. And getting rid of that squared means I'm going to square root. So r is going to be the square root of 19. And now I can just go ahead and find all 6 trig functions. So going ahead and plugging them in. Please make sure you're solving for r correctly. Again, you are not using a calculator. Leave it as square root. Please pay attention to the 6 trig functions, because you're not just flipping them once you get the answer. You have to look at what you have. So going ahead to do the first one. If you need to write this down, please make sure it's written down somewhere because you have to know this. So I'm going to go ahead and find all 6. I have sine theta, and sine theta is y over r. Okay, so looking at it, y is the square root of 3, and r is the square root of 19. You cannot have a square root in the denominator, so you have to rationalize it. Multiply top and bottom by the square root of 19, and you're going to end up with the square root of 57 over 19, and this would be your answer for sine theta. All right, now going ahead and finding cosine theta. So cos theta is x over r. Do not forget to rationalize the denominator if you have to. So x is -4 over the square root of 19. You cannot have a square root in your denominator, so you have to rationalize it. I'm going to multiply top and bottom by the square root of 19. And I'm going to end up with -4 times the square root of 19 over 19. And this would be my answer for cosine theta. Okay, going to the next one, I'm going to have tan theta. Tan theta is y over x. So looking at it, my y is the square root of 3. My x is -4, and this is fine, okay? No square roots in the denominator, so this is fine, leaving it. Now, I'm not just taking the answer I got for sine and I'm not just flipping it. Pay attention to how I'm writing this. Okay, so cosecant theta is r over y. Okay, I am taking the square root of 19 and dividing it by the square root of 3. Take your actual r and y. Okay, so if we're looking at it, over here we solve for r. We had x and y, and that's what I'm using to plug in. So in this case, I still have to rationalize that denominator because it's a square root. And I'm going to end up with the square root of 57 over 3. Okay, so my answer is definitely a little different than what I had for sine. Let's go ahead and do secant theta. Secant theta is r over x. And plugging that in, r is square root of 19 over x, which is negative 4. And I'm going to leave it like that. And then looking at the last one, cotan theta, I'm going to have x over y. I'm going to go ahead and write it as negative 4 over the square root of 3. And for this one, you still have to rationalize it. You cannot have your square root in the denominator, so it's going to be negative 4 times the square root of 3 over 3, and that's what I'm going to have for this one. So please, you cannot have a square root in your denominator. Do not forget that. All right, going ahead and looking at the next one, it says still find the 6 trig functions for angle theta whose terminal side runs through these points. So again, I still have my x and y. So writing that there, here's my x, here's my y. I have to go ahead and solve for r. So I'm going to have negative square root 3 squared plus negative square root of 2 squared equals r squared. I'm going to end up with 3 plus 2 equals r squared. I'm going to get 5 equals r squared. And getting rid of that squared, I'm going to go ahead and square root it. So in this case, r equals the square root of 5. Going to go ahead and write them all down. I have x, which is negative square root 3. I have y, which is negative square root 2. And r, which is the square root of 5. Okay, plugging it into my ratios, or my trig functions. Okay, have to memorize this again. I said write it down multiple times. Promise you it'll get stuck in your head. You have sine theta. Sine is y over r. So I'm going to have negative 2, or this, sorry, negative square root 2 and the square root of 5. Rationalize it. You're going to end up with negative square root 10 over 5. Going to cosine theta. Cosine is x over r. Negative square root 3 over square root 5. Again, rationalize it. And you're going to end up with negative 15, or negative square root 15 over 5. And then going ahead to tan theta. And tan is y over x, which is negative square root 2. Forgot that square root. Over negative square root 3. Negative and a negative is going to give me a positive. But don't forget you have to rationalize it. So in this case, I'm going to have positive square root 6 over 3. So those are my first 3. And going ahead and doing the reciprocals. So now I'm going to have cosecant theta, which is r over y. And I'm using the square root of 5 over the square root of 2. Okay, rationalize it. And I'm going to end up with the square root of 10 over 2. I'm going to have secant theta, which is r over x, negative 3, or not negative 3, it's square root 5 over negative square root 3. Okay, rationalizing that square root 3, and I'm going to end up with negative square root 15 over 3, and then cotan theta, which is x over y, negative square root 3 over negative square root 2, still rationalizing it, and I'm going to get positive square root 6 over 2. Okay, so this is what I would have for the last 3. Don't forget your signs. Okay, going ahead and going to number 7, it says find sine theta if cosine theta is negative square root 5 over 2. Keep in mind these two are inverses, so all you have to do is flip it. So sine theta is going to be negative 2 over the square root of 5. But remember, we have to rationalize it. You cannot have a square root in your denominator. So I'm going to get negative 2 times the square root of 5 over 5, and that would be my answer for this one. Same thing with number 8. Cotangent is the inverse for tan. So all you have to do for this one is the reciprocal, negative square root 3 over 3, and I don't have to change anything here. This would be my answer. All right, looking at the next one, number 9. It says, find the 6 trigonometric function values for theta if sine theta equals negative 4 over 7, and theta is in quadrant 4. So this is when I have to use that rule where it's all students take calculus, and if I'm looking at quadrant 4, the only ones that can be positive is cosine and secant. Okay, so after writing all my 6 trig functions, those are the only ones that can be positive. Everything else is going to be negative. So if I'm looking at it again, sine I know is y over r. I have to go ahead and solve for x. So labeling a couple things, I have looking for x, y is negative 4, r is 7. Let's go ahead and solve for x. I'm going to use x squared plus negative 4 squared equals 7 squared. And just solving for x squared plus 16 equals 49. Subtract 16 from both sides of my equal sign. And I'm going to get x squared equals 33. And getting rid of that squared, I'm going to square root it. So x equals the square root of 33. So just go ahead and writing that in. And then go ahead and writing those functions, all 6. All right, just writing them out again. You cannot have a square root in your denominator. So I'm going to go ahead and start. I have sine theta. And sine is y over r, which is negative 4 over 7. That's good. Cosine theta is x over r, which is good. Tan theta, which is y over x. Going ahead and rationalizing this one. I'm going to get negative 4 times the square root of 33 over 33. Going ahead and doing cosecant theta, which is r over y, 7 over negative 4. Secant theta, I'm going to get 7 over the square root of 33. Can't have the square root of 33 in my denominator, so I'm going to go ahead and rationalize it. And that's going to give me 7 times the square root of 33 over 33. And then cotan theta, which is x over y. And that's fine. So those are my 6 trig functions, and just checking my signs. Remember, the only ones that can be positive is cosine, which is positive. Okay, that's good. And secant. Everything else is negative, 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 and negative. So I got it. Okay, going ahead and going to the next page. All right, looking at number 10. Now I'm looking at quadrant 3. So quadrant 3, just going ahead. All students take calculus. That means I could only have tan and cotan that are positive. And if I'm looking at secant, I'm going to go ahead and change this to put it over 1. And this is going to be r. And my x, I have to go ahead and solve for my y. So just labeling x is 1, y I'm finding, r is negative square root 5. So going ahead and solving this, I'm going to have 1 squared plus y squared equals the square root of 5, or negative square root of 5 squared. 1 plus y squared equals 5. Subtract 1. I'm going to end up with y squared equals 4. And square rooting it, y I'm going to end up with 2. Okay, for this one, pay attention to your signs in the end. So if I'm looking at this, just going ahead and writing them again, I have sine theta. Sine is y over r. Y is 2 over the square root of, or negative 5. Okay, rationalizing this one, multiplying top and bottom by the square root of 5. I'm going to end up with 2 square root of 5 over 5. Looking at the next one, cosine theta, x over r. So I'm going to have negative, or I'm going to have 1 over negative square root 5. Rationalize this one. So I'm going to end up with negative 1 square root 5 over 5. And tan theta, which equals y, y over x. So that's 2 over 1, which just gives me 2. Okay, that's now going ahead to cosecant theta. I'm going to have r over y, which in this case is the square root of 5 over, or negative 5 over 2. I'm going to have secant theta, which is r over x, negative square root 5 over 1. And then tan theta, or not tan theta, cotan theta. Cotan theta, which in this case is x over y, which is 1 over 2. Now going ahead and checking, tan and cotan should be the only ones that are positive. So this is positive, this is positive, everything else needs to be negative, which is correct. Okay, going ahead to the next one. It says use the Pythagorean identities. You must use the Pythagorean identities for this question. It says find the cosecant theta if cosine theta is negative 2 over 5 with theta in quadrant 2. So I'm still using the all students take calculus for quadrant 2. And going ahead and using the Pythagorean identities. They're giving me cosine. So if I'm looking at my options, I know I'm going to use the first one. I have cosine, I can use cosine. Okay, now if I'm solving for that first one, I get sine. But something we should know, sine and cosecant are, they're flipped. So I have cosecant theta, their inverses, equals flipping it, sine theta. Okay, so I'm going to show you how this is going to work. So plugging in what I have sine squared theta plus negative 2 over 5, keep in mind it's squared, equals 1. So now I'm going to have sine squared theta plus 4 over 25 equals 1. I'm going to subtract 4 over 25 to both sides of my equal sign. Keep in mind, when you have fractions, you have to get a common denominator. So I'm now going to have sine squared theta equals 25 over 25 minus 4 over 25. I'm going to get sine squared theta equals 21 over 25. Square rooting it to get rid of that squared. Sine theta equals the square root of 21 over 5. Now, this is sine. I have to get cosecant. This is what I'm trying to find. Sine is y over r. Cosecant is r over y. So going ahead, cosecant theta is going to be 5 over the square root of 21, but I can't have the square root of 21 as my denominator, so I'm rationalizing it. And I'm going to get cosecant theta equals 5 times the square root of 21 over 21 and quadrant 2. All students take calculus. Here's quadrant 2. Sine cosecant must be positive, and it is positive, so this is my answer. Okay, going ahead into the next one. Using Pythagorean identities, find tan theta if cosine theta equals negative 5, the square root of 5 over 4, with theta in quadrant 2. Looking at this, cosine, I'm trying to get tan. For this one, I'm going to go ahead and use the second identity. Why? Because cosecant and secant are inverses. Cosecant, or not cosecant, cosine theta and secant theta. So pay attention to what I'm doing first. I have cosine theta, which is negative 5 or negative square root 5 over 4. I'm changing it to secant theta, which is now negative 4 over the square root of 5. So that's what I'm plugging in. So now I have tan squared theta plus 1 equals negative 4 over the square root of 5. Keep in mind it's squared. So now I'm going to have tan squared theta plus 1 equals 16 over 5. Subtracting 1. So I'm going to have tan squared theta equals 16 over 5 minus 5 over 5. Bringing this over here. I'm now going to have tan squared theta equals 11 over 5. Get rid of that squared by square rooting. Tan theta equals square root 55. Rationalizing this over 5. Now, quadrant 2. All students take calculus. And quadrant 2 again, the only ones that can be positive is sine and cosecant. This is not one of those. So my answer is going to be tan theta equals negative square root 55 over 5, and that's my answer. Please make sure you guys study. You have a quiz tomorrow.